Here we go. This is the review. I'm going to work these out because I'm making a video for my other class. So you can listen if you want, or you can try to work on your own. But question 1. The directions are to determine if AB, this is A right here, this is B. We've got to determine, I'm going to outline this line in blue. We have to show that if it's a tangent line. We can't just assume. The directions don't say assume if it appears to be tangent that it is. We have to show that it is. That means we have to show that that angle right there is what kind of an angle? We have to show it's 90 degrees. Well, it's a triangle, isn't it? How do we show that this is a right triangle? We have to show that this satisfies the Pythagorean theorem. Does a squared plus b squared really equal c squared? You guys following? Here's a big potential mistake students are going to make. What is the length of the hypotenuse? 19.4. Partner, where did 19.4 come here?
You don't have the measurement for the radius.
We don't know what this is. From here to here is 6.4, but this is a radius. Like Parker said, this is a radius. The radius is the same no matter where it is. So if this is 13, what's this? 13. So what's the entire length of that side? 19.4. So what we have to show is, does 13 squared plus 14.4 squared, does that really equal 19.4 squared? Is that true or false? Well, that's something you got to check on a calculator. Does 13 squared plus 14.4 squared really equal 19.4 squared? This is a yes or no answer, you guys. So this is a calculator problem. So 13 squared is 169. 14.4 squared is 207.36. 19.4 squared is 376. So if I add 169 to 207.36, that's supposed to equal 376. So 169 plus 207. 169 plus 207.36. And it does. This is a true statement. That means this is a right angle. And in turn, what does that mean? It means that line AB is tangent. So the answer is yes. AB is tangent. Now question 2, I think they're asking same thing. But again, I can see students making a pretty big mistake here. Take a look up at the screen. We're supposed to determine if this line I'm highlighting in blue, we're supposed to determine if that really is tangent. So we have to show that that's a right angle. So we got to do another Pythagorean theorem. A lot of students are having trouble figuring out the A, the B, and the C of Pythagorean theorem. Which one's the hypotenuse? C. But which one on this triangle? 17. This is the hypotenuse right here. So we have to figure out is 7.2 squared plus, you guys be careful, 7.7 is only the length from there to there. That's the radius. What's the entire length of that bottom side of the triangle? There's another 7.7 here, so it's 15.4. So you've got to see, does 7.2 squared plus 15.4 squared, does that really equal 17 squared? And I don't think it's, maybe it is, I don't know. 7.2 squared plus 15.4 squared. That equals 289. What is 17 squared equal?
289.
Hey, look at that. That means that that's a right angle. What else does it mean? That it's tangent. So the answer here is also yes. You understand what they were asking on questions 1 and 2? Okay, question 3 and 4 are now different. They're not asking for the same thing. You're still given a similar style of picture. But now you can assume, if the directions clearly say if a line looks like it's a tangent line, then you can assume that it is. So doesn't it kind of look like this line that I'm highlighting in black? Kind of looks like that's a tangent line, right? So we can assume that it is, which means we can also assume that's a right angle. That makes this a right triangle. Wait, slow down. Say that again.
9.8 plus 7.2 equals 17.
This whole entire side is 17. You're correct.
And then that 7.2 also correlates with that one because they're both in the center.
Did you guys hear that? What is this length right here? Why is it 7.2?
Another radius.
It's another radius.
And then you do 17 squared plus 7.2 squared.
Close, but that's a common mistake, you guys. What side of the right triangle are you trying to find? The hypotenuse or one of the legs? We're trying to find one of the legs, you guys. You need to look carefully. 17 is the hypotenuse. Yeah, so we've got to figure out one of the legs. That means it's either A or B. And it doesn't matter. Call it A, call it B. I'm going to call it A. So A squared plus 7.2 squared equals 17 squared. This is the equation we have to solve. A squared plus 7.2 squared equals 17 squared. That equals 289. That's if you multiply. We're squaring 51.84 plus A squared. So we subtract 289 minus 51.84. Then you square root. You get 15.4. So that question mark was equal to 15.4. I'm going to let you guys try 4 on your own, but what is number? I mean, aren't you going to do the same thing pretty much, Pythagorean Theorem? Yeah. But on number 4, let's be clear before we move on. Listen carefully. What side of the right triangle are you trying to find? The hypotenuse or one of the legs? Hypotenuse. So that makes it a little bit easier if you're trying to find the hypotenuse. Okay, turn to the back. Okay, you guys, this problem number 5 is going to take a little bit longer. Okay, I need you to put that away. Thank you. Everybody look up at the screen, please. Here's the property that we learned regarding this type of problem. Listen carefully. Look at the point I'm highlighting. That's a tangent line. Let me do this in a different color. That's a tangent line, and that's a tangent line. Would you guys agree? And it says in there, assume that lines which appear to be tangent are tangent. So that's a tangent line, That's a tangent line. The theorem that we learned about is if there's a point that has two lines that are tangent to a circle, then those are congruent segments to the point of tangency. So from here, those are congruent segments. Do you remember we talked about this? It's been a while, but we did do an assignment like this. So why is that important? Well, take a look at this, you guys. If from here to here is 6.1 and the entire length is 12.6, couldn't we figure out that length there?
Yeah.
But if we figure out that length, haven't we figured out that length also?
Yeah, 6.5.
So, what's 12.6 minus 6.1? That's 6.5. Well, what does that mean this is?
6.5.
6.5. Now, we're going to do a same trick. We'll do this in a different color. This segment and that segment, they're congruent segments. If the entire length here is 9.7 and that piece of it is 6.5, then this is 3.2, which also means that this is 3.2. Now we have a similar thing here. From here, that's a congruent segment to that segment. If the whole entire length is 11.2 and that little piece is 3.2, doesn't that leave that to be 8? But that also means that that is 8.
That's 6.1.
If this is 6.1, then this is 6.1.
That makes 14.1.
That makes this whole thing 14.1. The perimeter is adding up all the sides. So now that we know all the sides, you add them all up. That's the perimeter.
I got 47.9. 47.6.
Everybody's getting 47.6, it sounds like. Question 6 is very similar. Okay? Let's move on to question 7.
How many pages of review are there? 3.
I think there's 5. We're going to get through 2 of them today, 3 of them on Friday. So we're going to spend the first 40 minutes of class doing the review. The last,
Might not even get through 2 today.
the next one's pretty quick. Oh yeah.
Great.
Most of it, if you can get through it.
Okay.
Spring break seems like a good time.
Yeah, you guys aren't going to review on spring break.
No.
Sounds
Let's do
like
the test on Friday.
It would be in your guys' best interest if we get the test done before spring break. Trust me. All right.
Do you really think anybody's going to worry about the fact that they'll get on spring break?
Nobody will.
I'm not even going to remember.
Okay. Let's get through this. Come on. This is number 7 on the review. It says, assume that lines which appear to be tangent are tangent. That means this line here and that line there, those are tangent lines. They are also congruent because they're coming from the same point. But why is it important that they're tangent? Doesn't that make that a right angle? And that a right angle? I mentioned this briefly, but I'm going to mention it again. If a shape has 4 sides to it, the sum of all the angles inside is 360. Let me repeat that. Does this shape have 4 sides?
Yes.
Yes. If you add up all the angles of a 4-sided shape, what's the sum of all the angles? 360. So we already know 3 of the angles. This is 90, that's 90, that's 70. Wouldn't that help us find that missing angle there? It's not, but it's helpful. What's 90 plus 90 plus 70? 250? So then if we subtract that from 360, we get 110. So this angle is 110. Now look carefully at what you're supposed to find. You're supposed to find this little angle down here in red. Yes? It's not cut in half though.
You know that the triangle.
It's not cut directly in half. Okay. Did you guys hear that? Isn't this a radius right here, you guys? This one in red, and isn't this a radius? That makes this an isosceles triangle, which means that these little base angles are the same. There's only 70 degrees left because there's already 120 or 110 degrees of the vertex. If you split 70 in half, what do you get? 35. Number 8 is pretty similar. Now, number 9 and 10, you guys, I'm going to have you guys do this at home. Numbers 9 and 10 are super easy. 11x plus 3, what does it equal to? Negative 1 plus 12x. You just set up an equation. 11x plus 3 equals negative 1 plus 12x. If you set up an equation, and I'm pretty sure most of you in here could solve a simple equation like that. 11x plus 3 equals negative 1 plus 12. What about number 10? What is x plus 28 equal? Well, doesn't it equal the other side, 2x plus 28? So you set up an equation, you solve for x. That's the tangent line review. Okay, we don't have a lot of time. We are going to do this pink one.
How do you know what the triangle is isosceles?
It has two congruent sides.
If the congruent sides come from the sides of another shape,
It's called the radius. I know it.
That's a good point. Okay. This next one is the section called chords. This was from section 7.2 in your notes, chords. Okay. Question 1 is question 1 even really a question?
Yes.
I mean, it is a question, but
Is it a good,
Four.
was it a good idea to make that?
why is x 10? Look, isn't x a radius from the center of a circle out? Isn't that a radius? Where else do you have a radius on there? The other side is a radius. So x has to equal 10. Radiuses are the same. Okay, so question 1 really isn't that bad. Question 2 also isn't terribly difficult. You have to think a little bit more.
Wouldn't x just be 6.2?
I've tried to draw the same thing that you guys have on your paper up here. Parker, you had a pretty good idea.
Since the radius right there is 12.4, and then another radius right there, you just subtract 6.2.
Exactly. Did you guys hear that? Isn't this a radius?
yeah,
Isn't that also a radius?
6.2 is the segment of the radius you got to find the rest of it.
6.2 is from here to here. This entire length has to equal 12.4 because it's a radius. If this side is 6.2, what does the x side have to be? It also has to be 6.2 so that it equals 12.4. So that also wasn't terribly difficult. Question 3. Okay, let's talk about question 3. That's 14.3, not 143. How do we find this missing side x? It's all it is Pythagorean theorem, right? You have to be clear though on what side of the triangle you're thinking.
A squared plus 14.3 squared equals 15.7 squared.
Did you guys hear that?
No.
This is a right triangle, isn't it? Right here.
Oh, I squared plus B squared.
So it's just a squared plus b squared equals c squared. But what side is it we're trying to find? Is it a leg or is it a hypotenuse? It's a leg, so that means it has to be a or b. It doesn't matter, call it one. I'm going to call it a. So it's going to be a squared plus 14.3 squared equals 15.7 squared.
What are we getting? You got 6.5? You got 6.5? Anybody else? Got 6.5, 6.5? All right, we'll take 6.5. That missing side is 6.5. Now, number 4, you have to use that property that I just mentioned. This one's got a lot of parts to it. What a great question this is. All right, we're supposed to find x. All right, listen carefully. The property I just talked about said that if we have a chord, which is this right here, this is a chord, if it's perpendicular to the radius, that means each side of the chord there is congruent. So if this is 13.7, then over here is 13.7. So now we have two sides of this right triangle. Using Pythagorean theorem, that will help us find that side, but we don't, that's not what the question is asking for, right? Would it really help to find this side right here? Yeah. Because x is part of a segment that's a radius. We know that there's a radius over here that equals 17.4. So if we know this piece, we can subtract it from 17.4 to find this piece here. So we got to find that missing piece. Again, it's one of the legs of a right triangle, so let's call it A. So we got to find a squared plus 13.7 squared equals 17.4 squared. And again, I'm sorry that I'm going to have to move this one. Has anybody gotten far enough to find this, not the answer, but this little piece here? Who thinks they've got it? What did you say? 10.7. You got 10.7? So this little piece here for A is 10.7. If you subtract that from 17.4, that'll give you the missing piece for X. So 17.4 minus 10.7 is 6 point something. 6 point. What do we get? 6.7. Okay, that is from the, bless you, that's from the pink page. Let's go to green. This is the one that took 2 days. Remember that one? We had one lesson, we had another lesson on it. This one was, initially this was a challenging assignment for you, but I think, or at least I hope it's gotten easier. You guys did pretty good on the quiz. supposed to find the measure of that question mark. What's this called, by the way, when you go around the outer edge of a circle? Did I miss something? Oh, from C to W. That's right. Yeah, it's called an arc. We need to find the measure of the arc. Remember, it's the measure of the arc, not the length. Those are two different things. The measure of an arc is kind of like an angle measure. The length is in feet or in inches or in yards or whatever it is. We'll get to that later. There's all these lines on here to distract you. We really don't need all these lines. We have this angle right here. Consider this angle. That angle is 53 degrees. Now you have to consider what kind of angle. We learned about two different kind of angles, inscribed and central. You guys tell me which one this is, inscribed or central. Inscribed. The vertex is on the outer edge of the circle. We learned a very important property about inscribed angles and the relation to arc measure. What was that property? The arc length is the same or what? What is it? Or is it double? It's one of those two. It's double. With inscribed angles, the arc length is double. So if the angle is 53, the arc length, or sorry, the arc measure, not the arc length, the arc measure is 106. Alright, now we're going backwards. I didn't draw that super well. That's supposed to be an inscribed angle right there. The vertex is right there in the circle. You have to use a very often overlooked fact. I hope I mentioned this enough during the lesson that you don't overlook it anymore. But isn't this a diameter? Which means that's half of a circle right here. So that's 180 degrees as an arc. If this piece right here is 100, that's 280. So what does that leave for the arc right here? How do we know that? What is it all the way around the circle? 360. If we have 280 already of this portion, that leaves 80 for that little arc. So then the angle is 40 degrees. Because an inscribed angle is half the measure of the arc. Ooh, I didn't do that one very well. That doesn't go through the center. Kind of comes more like that, isn't it? And there's one from C to B. There we go. That's 38 degrees. Okay. Help me out here.
On the arc,
Which arc?
CE.
we can find the arc from C to D because that's the intercepted arc of that angle right here. If the angle's 38, what's the arc? The measure of the arc is 76. Now we can also find the measure of that arc. Stay focused, you guys. Stay focused here. This is a diameter, correct?
Yeah.
Which means that from D all the way to B, this half a circle, 180 degrees. This portion is 76. So what does that have to be to make it 180? This has to be 104 degrees. There's your equation. What does 33x plus 5 equal? It equals the measure of that arc, which is 104 degrees.
Let's find what you just went, 76 plus 33x plus 5 is equal to 1.
You could do that as well, yeah. You could say 33x plus 5 plus 76 together equal 180, and then when you subtract the 76, you get that 104 over there. Subtract 5, you get 33x equals 99, so you get x equals 3. Ooh, number 4 is a tricky one. Okay, you guys tell me, true or false? Ready? Here we go. 22x plus 7 equals 46x plus 6. True or false? Is it true or false? We got a couple of votes for false. Is an inscribed angle equal to the arc? No. So this is false. So we can't put an equal sign between them. Which one's more? Is the arc greater or is the angle greater? Which one's greater? The arc, isn't the arc twice as much as the angle? You guys need to listen carefully. Okay? If the arc is already twice as big as the angle, how can I make these equal to each other? Because I want to put an equal sign here. But if this is already twice as big, then don't I have to multiply that by 2 to make it equal what this is? Now, was that a true statement? That's a true statement. An angle, or an inscribed angle, the arc is already twice as big. So if you multiply the angle by 2, now they're the same. So you have 44x plus 14 equals 46x plus 6. Now you solve. Minus 44x. Subtract 6. And you get 8 is equal to 2x. And x is equal to 4. Find the measure of angle WUZ I would be so mad if I went to Little Caesars and they cut my pizza like that. Wouldn't you guys? What do you guys remember about central angles? These are all now central angles because they start from the center of the circle. This is a dumb question.
I don't know. I had to try to do it 3 times because I thought it was too easy.
The crap? Alright, I want you to cross this out. Not the problem, but what they're asking. This is stupid. W, U, Z. What's the measure from W to U to Z? You just add those 3 angles. Alright, that's stupid. Cross this out. Answer this question. What's the measure of angle V, U, Z? So if you start at V, go to U. This is U right here, by the way, in the middle. So what's the measure of that angle? That would be a much better question to ask. What's the measure of that missing angle? Well, not U right here, but on this side right here. If this has an arc measure of 61, what's this angle right here? These are central angles. Remember, central angle is the same as the arc. If the arc is 61, the angle of the central angle is 61. So we have all of these angles right here. How does that help us find this one? You add all of them up and subtract it from 360, because the circle has 360 degrees. So if you had 61, 40, 45, 70, add all those, subtract from 360, that will give you this. Anybody got it? What is it? 144? Okay, the directions say solve for x. Yeah. These are all central angles, which means there's no distinction between a central angle or an arc measure. They're all the same. If it's an arc measure, that's the same as the angle. Or if it's an angle, that's the same as the arc measure. They're all the same. This one is actually not so bad of a problem. What do you think?
This one looks a little bit weird on the paper. Is 55 and x plus 9 vertical angles?
No. That would have been, if this were a diameter and if the other one was a diameter.
It looks a little bit weird.
Yeah. How do we do this problem? Yeah. We know this arc is 95. We know that arc is 8x plus 9. That arc is 7x plus 6. That arc is 11x plus 13. That arc is 55. We know all of the arcs. We know the measure of all the arcs. So you add them all up. 55 plus 95 plus 8x plus 9 plus 7x plus 6 plus 11x plus 13. That all should equal 360. Should all equal 360. Okay. We have to move on. And that one you could solve pretty easily. What's the arc? Look at question 7. What's the arc given by angle 3? Arc CD. On number 7, what's the notation? You have to remember the correct notation. For number 7, if you just do this, is that a line? Is that a segment? Is that an arc? What is that? That won't get any points because I don't know what that is. What do? You have to put a eyebrow thing.
Look at that with your finger.
Put some eyelashes there. No, you don't put eyelashes in there. But if you mean arc, then you have to have the arc symbol. Arc CD. Now question 8 is specific. It wants a major arc for angle 2. A major arc is more than half of a circle. So if you just say arc TS, that's a problem. That's not more than half of a circle. You have to start at T and go the other way around to S. How do you specify that on number 8?
Yeah.
Arc T, R, S. Okay, let's go to the yellow, or I think the technical name for this is goldenrod or buff. I don't know. Arc length, sector area, this is what you guys had on the quiz last time while I was gone. That's a 285-degree angle. The radius is 15 inches. You're supposed to find the length now of the arc from here all the way to there. Length of the arc. Arc length S is equal to the radius times the angle. That's the formula for arc length. Radius times the angle. However, and it looks like most of you remembered this when I was looking over your quizzes from last time, you can't use this formula for degrees. It doesn't work. This has to be in radians. So you got to convert 285 degrees. We've got to multiply it by the correct conversion factor. What is it for degrees into radians? Pi over 180. Because now the degree symbol, or the degree unit of measure, is gone. And you got to simplify 285 over 180. That needs to be a simplified fraction, not a simplified decimal. Simplified fraction. So it's 19 divided by 12. This is 19 pi over 12. That's just the angle. That's not the answer. Some of you on the quiz converted it to radians and then stopped. You forgot to use the formula. This is just the angle. This is theta. So now you take S equals the radius, 15 times the angle now that's in radians, 19 pi over 12. And this also must be a simplified fraction. So on your calculator, type in 15 times 19. Hit enter. And then divide that by 12. That is not a decimal. Or that's not a fraction. I mean, that is a decimal. Turn it into a fraction. It's 95 fourths. Yeah. So the answer is 95 pi 4. And now you have to include the unit of measure. Inches. Question 2 would be just like this one. You have to convert the angle measure into radians and then multiply it by the radius. Okay? Question 3. We have 240 degrees. This is 8 miles. You're supposed to find now the area of the sector. This is That's the sector you're supposed to find. It's just a different formula. Area of a sector is 1/2 times the radius squared times the angle. So we don't know the angle in radians. This has to be in radians. 240 degrees is no good for this formula. So, same conversion factor, pi over 180 degrees. Degrees are gone. You need to know 240 divided by 180 as a fraction. It's 4 over 3. So the angle is 4 pi over 3. Now use the formula, 1/2 times radius squared. That's 64 times the angle, 4 pi over 3. I would now change everything into fractions and multiply everything straight across. In the denominator, you're going to have a 6. Because 2 times 1 times 3 is 6. In the numerator, 64 times 4 is what, 256? So that's 256 pi. And you simplify that fraction. 256 divided by 6 is 128 thirds. So it's 128 pi over 3 square miles. Question 4 is just like that one. So you have to, and there's no circle to look at. Use the same formula. Now to the blue one. What's that? No, we got to move on. This was the video you guys had last. How did that go, by the way? Was it a pretty easy assignment?
Yeah.
There were 2 on there that were kind of hard, where you had to use a distance formula. But other than that, it should have been pretty straightforward. Question 1 on the blue one now. I'm looking at the blue. The equation of a circle has to look like this: x minus h squared plus y minus k squared equals the radius squared. That's what the equation looks like. Where h and k, what are h and k? Or what is h and k? It's the center, right? And the radius is r. So on question 1, I give you the center. It's negative 12, comma 16. The center is negative 12, comma 16, and the radius is 1. You've now got to write an equation in this form right here. So something squared plus something squared equals something over there. What's it going to be? Now hold on there. X. Why is it plus? It's opposite. Yeah. If it's a minus here, it's got to be opposite in the parentheses. That means here it's going to be y minus 16. Now you square the radius. But 1 squared is still 1. Question 2, you have to locate the center on your own. So just look at the circle and find the center. Where's the center? It appears to be about 2, 4. Now start at the center and count straight over to the side of the circle. What's the radius? Radius is 2. Now we do the same thing. Make an equation. Something squared plus something squared equals the radius squared. It's going to be x minus 2, y minus 4 equals 2 squared, which is 4. This is what your assignment was on last time. Question 3, you have to identify. Now we're going the other way. I give you the equation, x minus 3 squared, y plus 9 squared equals 36. Students get so caught up in moving quickly through a test because they want to be done, they make a really dumb mistake on these kind of questions. What's the center? It's positive 3 and negative 9. You have to take the opposite. Positive 3, negative 9, and the radius is the square root of 36, which is 6. And on question 4, you have to graph the circle now. Given the equation x minus 1 squared, y plus 3 squared equals 9. The center is positive 1, it's the opposite of that, negative 3. So go over 1, down 3. There's the center of the circle. Radius is 3. So starting from your center, you're going to go out 3, up 3, over 3, down here, and down 3, in all directions. So there's 3 in that direction. 3 in that direction. 3 there. And 3 there. So you draw now the perfect circle. Ooh, ooh. Yeah, close enough.